Yo, what's up? We're back from a little bit of a, 2-day hiatus, and we're still working on snow. Although this time around we have introduced some tessellation to the snow, but we still have we have a few problems, which best case scenario we will solve them all today, but we will begin with this one. So you can see here that we tessellate depending on distance from camera. And then we displace... Fuck, is this gonna crash now? We displace based on distance from camera. Or we tessellate based on distance from camera. So further away we tessellate less, closer we tessellate more. And I also really need to get to the bottom of this crash, but whatever. The problem being is that this can lead to some cracks between patches that are tessellated a different amount. The crack is usually visible from the more tessellated part because we do some displacement after. So that's the first thing we want to get to the bottom of. And I know why it happens, where it happened, when it happens. I'm just not sure how we're going to solve this. So I'm going to start by doing some drawings. And then we can look into it more. Let's just see. It's one subdivision. We get 512 times 512. Let's do 32, 512, 0. Maybe. Let's see if it crashes. Okay, so let's see if I can focus this patch or select this patch. The worst thing with this crash is that it doesn't always happen at the same time. It's situational. Good morning, Geralt. Good morning. Good morning, Calvino. So we can see here that the patches closest to the camera tessellates the most, and then we do less and less the further away we go. And that's pretty nice. It works. The problem being, of course, if I do this, let's see here. Let's run over here, and then we move away from this point. So this popping we see here, we can probably hide this pretty well. We're gonna make the distance a bit further away as well, so it won't be nearly as visible eventually. But what we can't hide, and what we're gonna fix first, is these cracks here. And looking at it from here, it's pretty easy to see that we go from a patch that is tessellated, what is it, 16 times maybe, to a patch that is tessellated at least 32, but I will probably 64 times. So let me do some drawings, explain the problem, and then we can try and get to the bottom of it. How do I want to draw this? Okay, we can do it like this. So we have, let's say that we build a mesh that consists of 9 vertices, so 4 quads. And then we have, so we have quad 1. I'm gonna draw this one as dashed because we work with these as quads from the beginning right up until the end. I think Unity probably, or it probably gets converted to triangles after the domain shader. But we know it mostly as quads. We can do this as well. So this is our original mesh consisting of 4 quads, 9 vertices. Looks good, generates a correct way, except for the selection issue. But we're assuming that everything is good here. And then we start tessellating based on distance to camera. So let's put our camera right around here. View it like that. So this one and this one will be tessellated some extra times. For now, let's just make them tessellate 1 extra time. So we tessellate them like this. Doesn't really line up with this one, but this is good enough. And we tessellate this one the same amount. The problem is this vertex right here. Because, okay, we tessellate it, then we jump down to the domain shader. Domain shader is roughly our new vertex shader, so that's where we do a displacement. And here we have all the new vertices we actually interpolate. So for this quad, when we jump down to the domain shader, we have 9 quads for this one, or 9 vertices for this one, but we only have 4 for this one. We displace this one, and then we displace these 3, which means that this one will stick up more or less than the point on this quad. How can I wonder if the Unity terrain stuff is in the Unity CS reference lib? They have a neat way of solving this. Oh, you're probably right. It should be available. We might go searching for it soon. But we have a few approaches to solve this. We could either solve it in the domain shader by reading neighboring values, interpolating correctly and stuff like that, which I think might be maybe that's not the best solution. Another thing we can do, but this one is going to be a little bit tricky, and this is probably how I think Unity solves it, I think. Maybe. We'll see. So, if we have the same 2 quads, like this, so then we want to subdivide this one, but not this one, but we want them to be linked upright. if we feed them the correct tessellation constants, we can solve this. So I'm talking about these right here. So we pretty much tells the tessellator how many times should we subdivide each edge and how many times should we subdivide the inside. So we could do it in such a way that for this one, we want to tessellate the closest to the camera twice. So we want to get these quads. So we want to tessellate this edge once, or subdivide it once, this one once, this one once, but this one 0 times. The problem then is how the hell you would solve, or what you would set the inner. I wonder if this is even possible. Like, best case scenario, we would tessellate the inner once. This one we would tessellate once. I wonder if we even can do this, actually. But if we could skip this edge, it would be amazing. Yo, what's up, public float? What you making? That's a pretty broad question. Do you want to know the macro, what we're doing, what we're building, or the micro of it? But if we manage to tessellate it like this, we don't need to do anything else. So tessellate 0 times, or subdivide 0 times, once, once, once. But how the hell would you manage? Then Unity transforms this to a quad, this to a quad, this to a quad. Jando, this is next gen AI? No. I wonder if... I wonder if it's even possible. It's this one I'm worried about. Or if we get the order of them, in this case, could we do... We get a vertex here, how... So I wonder if this one will be triangulized like this. I want to see what happens if we do let's bring this one down a bit. I want to see what kind of tessellation we get if we set... Okay, let's focus on only tessellation right now. Let's experiment a bit with tessellation. So we can use... let's see here. How I want to do this. Okay, if we just do it like this. If we bring out the plane here, bring it up, scale it to 10 times 10, and then we add snow terrain material. What do we get? And then we remove move this, and we do we just keep it as is. Snow vertex. And we comment this out as well. Okay, interesting. We still displace this. Position center vs. UV step, we don't use UV step anymore. Okay, this is interesting. Position vs. We interpolate bilinearly here. Definitely looks like we're displacing it. Oh, yeah, of course. We need to fix so that this one is quads instead of triangles as well. I wonder if it's enough to do. Okay, not really what I want to see. Easier way we can do this. Fuck it, in this case I want to do it like this. Let's delete this one. Let's hide those 4 things and let's add empty. So 0. And let's do like what I want to do now is I want to experiment a bit with this tessellation based on distance. I don't want to do it without the displacement and stuff. So we need a mesh that is just quads, single plane, doesn't take activity data or whatever. So let's create this mesh ourselves. Nice. Resolution, what do we want to do? 4 times 4 maybe? Something like this. Don't we have a sync between VS Code and Unity? Jeez. Test squad, material, snow. Okay, perfect. Now we can start experimenting a bit. Might want to change max amount. Let's go down to 5 maybe. Is this 5? What do we have? 2 to the power of 5. What is that? 2, 4, 8, 1632. Is that so? Sixteen looks to be all right. Yeah. So I want to see what happens. Because now we should be able to make changes in the shader and see them appear instantly. So I hope. I want to see what happens if we do... We take this one. So inside 0, tessellation amount, inside 1, tessellation amount minus... Let's do it like this. -1. So inside edge number 2 or number 1, if we do 0 indices, is going to be tessellated 1 amount less. Okay. Okay. So what happens here? I was still... maybe. Maybe we can go with something like this. We can see here. We still get this weird stuff here, however. So 3 vertices are paired with 2 vertices, and then we're gonna get cracks. But if we would reduce this one as well, I wanna see. And then if we take, and let's go with edge. So now one outer edge should be less tessellated. Is that it? It's this one for sure, isn't it? Look at this. So now we actually get a good pairing here. 2 vertices synced to 2 vertices. We could probably do something with this. What I'm worried about is, can we do it like this? like this is exactly what we would like to have. Now we just need to figure out a nice way to automate this based on distance from camera. So can we do that? Harukana, that looks good indeed. Yes, we can work with this 100%. So I wonder if it's structured as nice as this in here. So what we have is we get a patch with 4 vertex shader outputs. So a patch represents a quad, so we pretty much get 4 vertices. We want to output, let's see if I can paint this. So what we get here is 4 vertices, that's our patch. We want to output 6 integers. We want to output how many times we should subdivide. How many times we should subdivide each of these lines. And I wonder if the pairing is like this. So edge 0 is the edge that is created by by vertex 0 and vertex 1. Edge 1 is the one that is created with patch 1 and 2. 2 is the one created by 2 and 3. And 3 is the one created by 3 and 0. And then as for the insides, I wonder if 0 is the one created from the middle point of these two and these two. And then number 1 is the middle point created by these two and 3 and 0. So if this is, I think we did it like this, 0. We send it in like this though. So maybe can we debug this in some nice way? Because if we get the pairing correctly, then we can do the, when we calculate the tessellation amount, we do it based on, so we calculate this tessellation amount, the distance from the camera for each edge, and then we subdivide them. Which means that this edge and this edge will get the same subdivision. We'll see. It looks, let's see here, I need to, what do we have? X, Z. Let's start by doing this instead from the beginning. We can double check some stuff here. So when we create the vertices, we do it by, we create them upwards first and then to the right, but that doesn't really matter. What matters is this. But we go from minimum X, minimum Z to maximum X, maximum Z. And then when we set the indices, we do from up. Okay, we actually do it like this. Okay, that's beautiful. So we do it like the best result we get when we do it like this. Da, da, da. So I'm wondering if edge 0, 1, 2, 3, and then question about this one, so 0, 1 maybe. We can try this, we can test this. So if we change the 0, 1, if we subdivide that one less, it should be this edge right here. I'm pretty sure. So if we bring this one down 1, what happens? It's this one. That SN1 shaders always looks like wizardry to me. Everything else in program I can understand, but shaders are so unintuitive to me. It's a different way of thinking, but you have to think way more in parallel, I would say. But yeah, I do agree with you. It's just that I've grinded shaders quite a lot, so they make a little bit more sense. But okay, so if this one is 0, so this one is 0, is everything just offsetted once? So if we do, it would be so nice. 1, and we get this one. So I guess 2 and 3. Two and 3. Just need to double check here. And we start with bottom left. Yes, okay. So what we have, maybe I should do some more effort into this. Drawing. So we have quads like this. And I'm going to call them, so this is our edge 0, edge 1, edge 2, edge 3. The inside is going to be a bit more. So let's bring this one down to, okay, so we tessellate once. Okay, so I guess this one is edge 0. Let's see if we can make sense out of what we get here. Not really, no. It definitely looks to be this one that is edge 0, right? Because this edge we subdivide more times now, right? But how exactly does this work? This is interesting stuff. Yeah, we just subdivide that one less time. So if we would be doing -2, we get this one. So yeah, we subdivide this one less times. Okay. We're getting closer to understanding this. So this one, I'm gonna call it inside 0. Then we have this one, which is inside 1. Yo, what's up over on YouTube? Never know how to pronounce that name. But what is happening now? Trying to build some knowledge around tessellation. Unfortunately, I'm sure if you search the internet, you will eventually find some good information. But I haven't been able to with my quick searches, so we're just building some knowledge here by old school trial and error, which I actually enjoy the most. We're still doing tessellation, we're just trying to understand it better. So this definitely seems how we're just trying. So if we take a look at the tessellation implementation, we have something called a hull shader patch constant function. This one pretty much outputs how we should tessellate each edge in our geometry. For a quad, we have 4 outer edges and we have 2 inner edges. I'm just trying to figure out or try to map them. And we have mapped them like this. So in this case, if we tell edge 0 to subdivide 0 times, that means that this edge won't be subdivided. And then we have the similar thing for edge 1, 2, and 3, and inside 0 and 1. Because what we want to do is we want to, like, previously we subdivided or we tessellated based on distance from camera. The only thing is that we took these 4 points we get in, and then we do a bilinear interpolation to get the middle point of the quad, and then we base the full tessellation of the quad only on this vertex in the middle, which means that we don't get as dynamic tessellation as we would like to get. If we have neighboring quads, you get this tearing between them. So we can make this tessellation a little bit more dynamic by going more into detail, and instead of tessellating this full quad with 1 subdivision value, we tessellate each edge with separate tessellation constants, pretty much. Hopefully it will make a bit more sense soon. So what I want to do now, I want to find out the mapping of these ones, and honestly, so I want to know in this patch input, what order do we have here? I wonder if we can simply do, if we do float, we do position vs is equal to patch 0 position vs. So we just set it to the position of the first vertex making up this quad. What do we get? And then we bring this down a bit. 1 sec, what do we actually do with this one? We just use it here. What can we do? What can we do? Actually, we can do it like this. We base the tessellation amount on this position. So one way to test this is if we minimize the max distance to 1, which means that we need to be really close to the vertex at hand for it to tessellate. Not the best way to do this. Maybe I'm too far away. Let's do 2. Here we get a tessellation on this one. We don't get it at this point. We don't get it at this point. Not at this point, but if we get closer to this point over here, we get the tessellation. So that means that this is our 0. Yeah. So patch, let's do that one in green maybe. So this is at index 0. And then we can try it like this. So I guess we're gonna get 0, 1, 2, 3. But I want to make sure. So 1. Now we don't get any tessellation here anymore, but we do get it here. We don't get it here. Okay, yeah, I'm pretty sure. So 1. This makes sense, right? Let's make sure of 2 as well. And then we get the third one for free. Ooh. Hmm. 2. Did I? Okay. Actually, I'm gonna do this as well. And then we get 3 here. Okay, beautiful. And then we can bring back this one to 20 and zoom out again. Okay, so this is what we have. Edge 0 is edge between 0 and 2. Edge 1 is between 0 and 1. Edge 2 is between 1 and 3. Edge 3 is between 3 and 2. Inside 1 is between edge 1 and 3, and edge 0 is between edge 2 and 0. It's a little bit weird, this one. So it's pretty much like, I wonder why it's structured like this. I wonder if it's for an easier time to triangulate. But okay. So what we can do now is, I wonder how we want to do this. I wonder if we actually want to calculate maybe we want to calculate the edge constants for each vertex here. So we calculate 4 of them based on distance from camera. And when we set the subdivision amount for this one, we do it as min of S1 and S2, where S is the subdivision amount for vertex 0, 1, 2, and 3. So that means that even if this one is extremely close, its connected vertex is far away and subdivided less times, which means that we subdivide this one less. So this would, so we can do E, let's do SE1 is equal to this. My only question is how I want to handle the 4D. For the ones on the inside, I wonder if we want to subdivide, like, yeah, then we probably just want to take, so if inside 0 is edge 2 and edge 0, we take, so S I 0 is equal to min of no. I wonder if we want to take the min of whatever we subdivide this one and this one. Yeah, I think that's how we want to do it. Because if we think about the subdivisions here, so if we subdivide this one 4 times, so we make 4 pieces, they actually match to whatever this one is subdivided, because we're gonna get edges like this. So this one, when we subdivide this one, we should do it by SE1 SE3. Does this make sense? Ooh. I mean, we can try it. But we will most probably just get some fucked up result. Should I pull the trigger? Yeah, I think the edge, we can actually start with the edge ones and see how that works. Okay, so the problem here is we're gonna have to do this one each vertex in the patch. So let's tessellation amount. So I want to do let's do int calculate tessellation amount, and we want to send in float 3 position in world space. Yes. So we need this one. So we create a view vector, a vector between camera and position in world space. And then we calculate the distance of that. Instead of doing length here, we can probably do the length squared. We can work with length squared instead. That will optimize it a tiny bit, I think. Right. Optimize. I'm gonna have to take a look at this one. So we get the distance, then we do an inverse lerp between 0 and tessellation max distance. 1 minus to inverse it, and then we calculate tessellation amount by rounding. Lerping between, yeah. Round. I wonder if we should just go with a float here and return this. Then we remove this. We remove this. We probably don't need this one anymore. Remove this. And this. And remember, I don't want to... We want the final tessellation amount to be the 2 to the power of tessellation amount. I think we want to keep it like this. So we're gonna calculate, what is it? I always forget. Float tessellation amounts is equal to, we just do it like this, right? Let's do should backface call. We need view vector here as well. Oh. Okay, let's keep it like this then. Position. Let's rename this one to position center in world space. We need view vector here. View vector center. We do remove this one. Yep. Okay. And then I'm gonna try and do, let's see if we get a compiler error by doing float tessellation amount 3. Okay, beautiful. So what I want to do then is tessellation amounts 0 is equal to calculate tessellation amount patch 0.position world space. And then we basically just want to take this one and do it 4 times for each of these. So what we have done now is that we have calculated the tessellation amount per vertex. So I'm talking about the green ones here. So for 0, 1, 2, and 3. And now we want to calculate it for edge 1, 2, 3. But I guess we can do this actually. Float round. I think we can return the power to 2 here, so we don't need to do it down here. So 2 to the power of tessellation amount. So let's do how to like this. So now we don't need to care about that anymore. Okay, so then I want to bring this one back. I want to remove this. So now to what subdivision amount or tessellation amount, subdivision amount might be a better name, do we want to assign to each edge? So if we take a look at edge 0, it's this one. It's between 0.0 and 0.2. So what I'm thinking about then is doing this. So if this one is, if we have the camera here, this one is way closer to the camera, so this one might get a subdivision of 8, while this one only gets a subdivision of 4. Then I wonder if the correct... Wait, fuck, it's not really... I don't think we... So by this one we take the minimum, so we take this subdivision and subdivide this one with that. But I wonder... That's the correct way to do it. We can test it. Let's try it. So for edge, we take min of tessellation amounts something and tessellation amounts something. So for edge 0, that is 0 and 2, 0, 2. For edge 1, that's 0 and 1. For edge 2, that's 1 and 3. And for edge 3, that's 2 and 3. Ooh. I would like to test this, but I'm a little bit afraid we won't be able to do it in a nice way given our insides. Our insides are quite fucked. So let's take a leap of faith and try and get the correct tessellation here. And as for the inner ones, I'm wondering if we want to do it by... So for this one, no, for this one, we take the min of E1 and E3. So for the 0 one, is that correct? No. For this one, we take the minimum of this one and this one. This one take... Let's try it. Why not? So inside of these two, we're actually going to do use the output edge here. So for inside 0, which is this one, I want to go and do E1 and E3. So 1, 3. And for this, we then want to do 0 and 2. Okay, let's try this and see what we get. Worst that can happen, a crash. But let's analyze this result. Yeah. Okay, the next to worst thing that can happen, array index out of bounds. Okay, this looks pretty good, but I mean, it's not that brutal of a test just yet. We can see here we're extremely close to the camera. We get a lot of we get the tessellation max amount. This one is a little bit further away. We get this. Let's do max amount. Jesus, this looks pretty damn good so far, doesn't it? Jesus. Did we get this right on the first try? I think so. Seriously. Huh. I did not expect this. Okay, what's up, Graphic Edit? How's it going? It's going pretty damn good, I think. The only thing I worry about, actually, we're gonna do some quad flips later on to get, so we always want the quads to align with the gradient of the terrain. So if, yeah, I can put it like that. We're gonna do some quad flips later on to get a little bit of a smoother, smoother gradients. And in that case, I'm a little bit worried about this. How the hell do we flip this quad? But I mean, it's still a quad, I assume. Huh. I guess there probably exists a little bit of a nicer way to do this. We get some weird... But this will definitely solve the issue we have. Now we will always have a sync of points between patches, right? Fucking hell. And what is this, a game? Yes, eventually it's going to be a game. I have some videos over on my YouTube where I explain what the game is about and stuff like that. But in short, think Chow Garden, Tamagotchi, Viva Pinata. If any of those rings a bell. But more specifically right now we're doing snow, and to do some proper nice looking snow we want to do tessellation. Okay, I think we're actually ready to test this on the snow at hand. Although, I wonder... this information right here is definitely something I want to save. I want to save it for... Maybe I can do it off stream. I want to figure these things out for... when we work with a mesh that has a topology of triangles as well, which point is which edge is which, and which inside is which. But yeah, so what happens if we do max amount a lot here? It still works beautifully. Nice. Yeah, so we're gonna get some weird visuals on the edges, I reckon, but it's still This is gonna be beautiful, I think. I can't see something wrong with this one. Although I wonder, in this case, I wonder if it would be preferable to... So right now we have the... I'm gonna refer to these, the quads that make up an edge. So the set of quads that make up the outermost edge of one original quad. I'm gonna refer to them as the ugly ones, because you basically have one quad where 3 of the edges has the same subdivision amount, and then you have one that, so you pretty much break a quad into an n-gon, and then you triangulate it, or unity or whatever. But right now we have the... So when we go from a quad that is subdivided n times to a quad that is subdivided n plus 1 times, you get the ugly quads on the quad that has the least amount of subdivisions. I wonder if it would be better to have this one on the one that has the more amount of, but it might be as easy as just switching min here to max, I wonder. So if we bring down the... So you can see here, this is one quad here, the last line of edges here has the n gone. How would it actually look if we change it? I want to try it real quick. If it's as easy as changing min here to max, this might be the better option. So you can see here we get something like this then. This might be preferable, right? You get more even this has to be the preferable way to do it, right? Right. I'm gonna add a flag here so we can easily unclick or off-click it so we can see the difference. Maybe, depending on what we want to do with this stuff, one way or the other might be preferable. Look at this. Look at this. Extremely surprised it worked on the first try. Huh. Okay, so let's add a flag. I always forget exactly how we do that. So let's take a look at another shader. Which shader do we have? We have grass. And let's do... I don't want to do a... Actually, we can take a look at cell shade lit. Because here we have shadow screen. Now we have double-sided flag. Let's do that. Or toggle. Maybe we want to go with a drop down, even though we only have 2. Yeah, maybe we want to go with average as well. Didn't think about that one. That might be good as well. But let's see here. Where do we have brass fidelity? We have it up here. Pragma shader feature. Don't we have it? Keyword low, medium, high. Here, grass fidelity. Let's take this one. Do tessellation. This one, but this one. Tessellation. What do I want to call this one? Tessellation. Something with so. Because we're actually, so what we're doing is we have X amount of patches and we make sure that the edges are aligned. Maybe. Tessellation, so function. And for now, we're just gonna have min and max. But I'm wondering if I want to try average as well. Average. Yeah, that might give some interesting results. So what do we want here then? We want shader feature. Let's put it after multi-compile. And then we want to call it tessellation. So function min and tessellation so function max. And can we only do it here? If def. So then we do, which one gave the best result? It was max, I think. So if def this, do this, else do something, and if. Min. Something like this maybe. Let's see if we have some errors. Okay. So here we have min function. So if we take a look at this right here, we get quads like this. We get a quad and then it's split like this. Which can result in like when we go from one to another like this, you split one triangle in two. Not even that even, honestly. But if we do max instead, we don't get any difference. Why? What did I? Tessellation, so function. We might want to have. What did I miss? Yeah, why are our pragma shader feature? It doesn't have to do with the position, right? Okay. We don't get a highlight here. We do get a highlight here. Did I fuck up? Oh. High. There we go. Keyword enum. Low, medium, high. Grass. Fidelity. Oh. There we go. Minimum. Maximum. Why don't I get any difference? Did I misspell this? Tess. Could it be that we want to do that as well? Okay, that looks more like it. So if we compare minimum, in minimum we get these, which I'm not that big of a fan of. I can bring it down like this. It's a little bit more visible like this, right? So this is minimum. And if we compare to maximum, then we need to scroll out a bit as well. But what we do get here is these instead. So we get rectangular quads, while min gives us... I think I prefer max, even though it seems... Yeah, with max we're always going to tessellate a bit more as well. I'm trying to not think about that, but instead just how it looks when two quads meet. How does the tessellation look at the seams? And oh well, now we can choose between these at least. I wonder if we want to do it like this. Calculate tessellation amount. And then we take I want to create a method that pretty much does this for us. So instead of having the if def here, we can have it in a function, make it look a little bit prettier, not as many repetitive lines. And then we can also easily add additional ones if we want. So I also want to try average. I want to see how average look. Fuck. Maybe that's not such a good idea. Nah, let's go with max and min for now. So let's skip this one and let's see how it looks on the snow now. Hopefully we won't get the seams or visible seams between patches. Fuck, I haven't committed this one in a while. Okay, let's exit this one. Let's hide this one and enable these. And then we do, I also want to add back this. Is that enough? And then I remember we did some weird stuff this Monday as well. Here. Mesh grid delta. Yeah, fuck, we have. So this is something we want to handle as well. UV step divided by tessellation amount. Brain-based data size. I want to copy all of them. Copy change line 191. UV step is equal to this one, and then we remove the tessellation amount here. Any compiler errors? Yes. Undeclared identifier T. Output test. Okay, let's play and hope it doesn't crash. Okay, we do get snow. We don't see any seams, I don't think. We don't get that much. We don't get any displacement either, though. But snow looks to be working. I would like to up this a bit. Ooh, then we get displacement. Beautiful. Let's go with 10. No, don't I have any selection? don't I have my selection? Or actually, maybe we do. Let's not worry about that one for now. And then we have the popping like this, but that's good. It's a bit too much, but we can balance it by doing snow. Let's go 20. We could go up to 30 or even 40 maybe. $30 might be enough. We're always gonna have popping. It's just how we want to handle it. We can try and implement some sort of fade between them. That would be amazing, I think. Yeah, now when we have a better tessellation, we can experiment with that. Now when we have a better tessellation, dynamic tessellation, we can actually experiment by allowing for non-base 2 tessellations. Just see how it looks. So instead of doing this here, we just skip this. Wonder how that would look. So instead of going tessellation or subdivision amount 2, 4, 8, 16, 32, and so on, we go 1, 2, 3, 4, 5. So we get a little bit, but I wonder, it might be weird with quads, I'm not sure. And then we're gonna try and do quad flips as well, which will help with these jagged edges right here. Hell, this looks pretty good. If we do even more tessellation, okay, max amount 10. Is this really max? Maybe. I mean, more tessellation the better, but this might very well be enough. Let's see if I can. So here we have a jagged area. If we could just flip these quads, so flip this quad to here, this would look much better. Here as well. Flip this quad, basically. Yeah, the popping is a bit aggressive. It becomes quite clear to me here as well that when we colorize the snow, we colorize it based on vertex data, which means that we get interpolated like this. If we would do it, if we would recolor the snow base in the fragment shader, we would actually get very good patterns here. So that is definitely preferable as well. We would still get popping, of course, but it might not be as apparent. Hope my bro has Gore-Tex or he will have wet feet. We actually have a pair of rubber boots, but he doesn't have them on right now. So thinking about, this looks like very slushy snow. I just want to see if we can change to this. That might be true. Rubber boots might not be the best. We should get some Timbs as well. That might work. So let's see here. I'm gonna commit the current solution we have because it's pretty good. And then we're gonna experiment with the dynamic tessellation a bit more, I think. Jesus, like this is so cool. Actually, I love this. Whatever we get here. I also eventually I want to do some tiny bit more with the activity texture as well. So I want to randomize an offset to the minimum height we input such that when we walk over the same spot here, we still see some variation on the ground. But that's a bit in the future, I reckon. How can I not use my winter shoes in like 4 years or something? Hardly ever snow here or gets cold enough. Indeed. I think I'm pretty much the same. Although when I woke up this morning, we had some snow outside. Not enough for winter shoes, however. I'm gonna play around with this too much as well, I think. Probably want to... what happens if we bring this one up once? Ooh. Ooh. Okay, enough playing around. Okay, what do we have? I just want to make sure that 1030, 1030, and Max gave the best. That's all the changes we have. We put this one up a bit. Let's put it around here. Oh. That. Okay, beautiful. We're gonna exit this. We're gonna commit what we have, which is terrain procedural snow shader and the material in question. So 1 sec here, and we have done tessellate. Let's quit this one. More do we have? Materials as well. Environment material, rain, procedural, snow material. There we have it. I'm just going to put this as add tessellation to procedural rain procedural snow shader related to 131. Oh no. Okay, there we go. So now we can track whatever we change. Beautiful. The first thing I want to do is I want to disable. Here, let's go to character, show UI, and then I also wonder why my highlighter, let's just take a look at this one real quick. Oh yeah. I did some changes for a short, but that's not what we want to do. I think this should be enough. Okay. But anyway, I want to hide character environment. So these 4 again, and I want to bring back this. So our test quad. Because I want to do some small testing with this one again. I want to see what happens if we don't do 2 to the power on our tessellation. Let's bring this one up. Okay. Tessellate. Oh yeah, we want to lower this one again. So something like that. Let's see what happens now if we do. We remove power to 2 here. And do. Is this something I want? I hate that we why do we already lose this one? Is it because we give it some very weird... I mean, this would probably improve... This would probably make the popping a bit more smooth, but it would also pop a lot more. That's for sure. I know why we're losing this one as well. When we do the culling, we do it on the center of the quad. Still, yeah, that's weird. Let's see. Back face cull. Now we just do view direction. Tessellation view, frustum, tolerance. Max distance. We get some real fucked up tessellations here. There's gonna be a lot of moving snow, that's for sure. Let's do this. Every time it says game view repaint here, extremely afraid that we will get a crash. Let's see here, if we do max tolerance, yeah, what you're gonna get instead is a lot of popping like this. We probably want to do... Yeah, we want to move the vertices around as little as possible, that's for sure. But the question still remains. Is there anything we can do about... Let's see here. Is there anything we can do with... this? Yes, we can. Yes, we can. Okay, now we're gonna try and do something. Ooh, I want to try this with... So what we can do... Okay, so this is something we tried with the grass. shader. Didn't quite manage to do it, but this time around I think we have a bit more knowledge this time around. So if we always subdivide as 2 to the power of x, that means that vertices, they never move. We just pop in new vertices or remove old vertices, right? So this vertex right here, I don't know if this is supposed to, this vertex right here, we can take the middle vertex here. This one exists at this distance. It's going to exist in this distance as well, and it's always going to exist. Which means that we can try and figure out the age. Age might not be the correct word, but pretty much we can try and figure out the age of a vertex, like at what stage does this vertex exist? And compared to the distance we are, like for how long has it existed? Fuck, is it some better terminology I can use? But the idea is basically that when we pop in a new vertex here, if we just popped it in, we don't displace it in the height that much, or we displace it in the y direction depending on for how long it has existed. So when it just pops in, we don't displace it at all, and then the closer we get to it, the more we displace it. This will minimize the popping, but you will get animated snow, but hopefully it's done in such a way that it's really not that visible. But this is quite a hard thing to solve, I guess. So what we can do is that we can assign a value to each vertex, and then we render that value as a color, and hopefully that one will tell us how many times we have tessellate. Yeah. We can probably do it quite easily. So for each quad here, for each original quad, we have a UV value that goes between 0 and 1. So we know that each vertex has a UV value that is 0 or 1. And now each vertex has a value that is either 0, 0.5, 1. Now it is 0, 0.25, 0.5, 0.25. And if we can get this 0.25, so then we do and we do modulus. So we know here that the UV values that has, if we have a UV value that is a multiple of 0.5, it existed before. So 0, 0.5, 1, they existed before. But 0.25 and 0.75, they are new. And then we can... something like that. And this is exactly what we tried to do with triangles as well, but triangle tessellation not as structured as this, and barycentric coordinates a little bit more complicated than two-dimensional UVs. So this should be quite straightforward. Let's see. So let's add... okay, let's do this. We have test here, which we send out from the domain shader. We don't use it right now. We're going to add back return input.test. So now we color it as the test variable. And then we do let's add, okay, I thought we had one like this, but maybe not. Then in the domain shader, we try some stuff here. Yes. UV center, I think this is. So let's do output.test. We don't set this one anywhere else. No. Output.test is equal to UV modulus. We're gonna have to handle floats here, so we probably want some error margin or something like that. UV divided by, or modulus test is equal to 0. So if it's 0.5, yeah, something like this. Let's see what we get. Right now our test is 0, so, but if we do 0.5, yes. One sec. Dot x is equal to 0. Or uv dot y. So these are, we can do, if we do 1 here. So now we only have the original vertices, 0. Ah, fuck, we want to get rid of these, so we probably want to do and here instead. This one white, 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 black, black, black. So now we mark the vertices that existed from the get-go. And then we can do 0.5. Now we mark the vertices that appears on the first subdivision. 0.25, the vertices that appear on the second subdivision. And then we can just keep going like this. 0.05. Divided by 2. Again, and here we don't have any new vertices, but if we zoom in, we get new vertices. But we also want to calculate the age of them pretty much. So this works one more step. And one more step. Okay, this is fucking great. We can use this one. So now we have, right now it's a binary value, 1 or 0. We want to base it on the tessellation amount we have. I think... we get patch and we get factors as well. Oof. We have multiple different factors. How do we want to do this? So back to this one. Okay, so this one might be subdivided 16 times. So for a vertex around here, we want to calculate... do we really care about... Like, we want to calculate a tessellation value... So let's see here. I wonder if we can do this. So we calculate what tessellation value this point should have. Do that. Okay, I wonder if we can calculate the tessellation value this point should have. And then we go... One sec, just gonna grab a cup of coffee. Won't take long. Back. I wonder if we want to take the maximum subdivision for all subdivisions we have. So maximum for E1, E0, E2, E3. And that's the maximum subdivision we have within this square. And then we calculate the subdivision this point should have. And now we take the, yeah, we take the maximum. Maximum subdivision for the full square, that's our relative value. Now we calculate the, if we have that one, we can then do 1 divided by that one. That gives us the comparison value. If this one or we actually calculate x minus 1. Yeah, so I wonder, we calculate the maximum subdivision, then we actually want to do x minus 1. This is squared. This is, if it wasn't squared, we could do this. And yeah, I guess we can just do divided by x divided by 2, can't we? 32, 16 divided by 2. Which we could change to 2 divided by x if we wanted, right? But yeah, if we do this, and this is our compare value, i.e. that's this value. So instead of using test here, we do this compare value. So then we get, for this quad, we can mark the newest vertices, and when we have the newest vertices, then we can figure out how new are they really. And then we base the offsetting in the x or in the y direction on how new they are. But let's start with this and see if it's correct. So instead of doing test here, we want to do float compare value. And now I wonder, now we will probably get down to having to work with floating point errors. We can try without it first. So what I want to do is compare value is equal to 1.0 divided by max, and here we do factors, dot edge 0 factors dot edge 1 max factors dot edge 2 divided by 2.0. Or we can do it like this. Float max tessellation factor and then we do divided by 2. And then compare value. We're gonna do comparison by error margin. We're gonna have to, I think. We'll see. This looks to be correct, I think. Looks a bit weird here. Nah, not really. Or fuck, are we gonna screw this up? Maybe. Oh. Yes. This one will be sort of fucked. So in this case, we would offset this one, but not the other one. So we would get the seams back. Interesting. But if we do min instead, and then we don't divide by 2.0 here. Okay. Yes. I'll do min here as well. That's worse. That's definitely worse. Okay, so how can we handle the edges in this case? We could, I wonder if we do min here. There we go. So if we do it with this topology instead, it doesn't work. The problem is definitely the edges. So what can we do to exclude these right here? Now we pretty much want to get the we need to get the, so these vertices here. So it's a little bit of a problem because right here we want to, this one is black, we want it to, or this one is black, we want it to still be black. But this one right here is not. Or I'm talking about this one. Yo, what's up, Cooler SK? So which relation to water does this carpet pattern generator have? Or when we want to tessellate patches of water. Yo, what's up, Catboy King? Okay, if we take this one here, this one doesn't belong to the recently tessellated points, generated points to this one. But this sucks. We're still gonna have to we have the information to fix this. We can get it. I mean, if we want to do it in the most unoptimized way, I reckon, then we could add some extra information here. I don't know if that would help either. It would help, but I don't want to do it like that. No, you're right, Harukanan, I'm muted. I've probably been muted for the last 5 minutes. Sorry about that, everybody. What I'm getting at is, I wonder if we can take, for each patch, we take the maximum tessellation amount and the minimum tessellation amount. And then we get the range we tessellate, and then we calculate the tessellation amount for the point we're in at. If we're within that range, then we want to color it differently. I think we can try it, see what kind of output we get. Right? Maybe not the best way to do it, but I think it will work. I think it will work. Yep, okay, I started to wonder, though you could have just been thinking very hard. I have had very quiet sessions, that's for sure. Usually when I'm tired and annoyed that I can't solve a specific problem. So like if I've been banging my head against a problem for more than a couple of hours, that's usually when I start getting quieter and quieter. But this time around it was a unfortunate mute. I'm sorry. Like I try to mute myself when I drink or do something else, just to minimize the amount of annoying sounds, you know. What's up, GDs? So then I also want to calculate calculate tessellation amount. Beautiful, we have it as a method. So we calculate max, min, and then we do float tessellation amount is equal to calculate tessellation amount, and we just send in position center vs, and then I want to do output dot test is equal to invert slurp min tessellation factor max tessellation factor tessellation amount. GDs, what happened? Did you have the mic open and went to pee? That has never happened, I don't think. Try to make as sure as possible that that won't happen. Okay, this is not exactly what we want, but really? Okay. I think we want to do... I need to think. Nah, I think a better way to do this is we're gonna do some interpolation here. Let's see. Oh. I think we want to do bilinear interpolation between the edge subdivisions. So for this point here, we do interpolation between E1, E3, and then we do interpolation between E2 and E0. Because we could solve this by like if we figure out the closest edge, but can we do it like this? Basically, we want to differentiate between this point and this point. It's that hard. I was thinking about how does it look? One sec, let me revert. This one, let's revert it back to this one, I think. Like it's, in this case, we want this one to be marked as a new vertex for this one, even though it really isn't. Or I mean, it is. But we have vertices that are even newer, right? But we want to mark this one, but we don't want to mark this one. If we take the closest edge, we can see here that this one is new. But to do that, we need to figure out and that's why I thought, so if we take this one, which is the closest, we only care about this for edge vertices. Like I want to be able to, I was thinking that we could look which edge is the closest one. Some of the edges or inside. So for this one, this edge is the closest one. For this one, this edge is the closest one. But for this one, it's gonna be more complicated when we increase this one as well. Because this point is still closest to this edge, but this edge is way more subdivided than this point. So I wonder... Then again, I wonder... Factors... Let's do output dot test is equal to factors 0. Inverse lerp min tessellation factor max tessellation factor. What did I mean? Factors dot edge 0. Yeah, exactly. We get it for... Okay. Okay, in this case, this edge is a factor of 4, I think. This one as well. But these two has a factor of 8. So how do we exclude this point? But not this point. The edges that this point is closest to is like it's right in the middle between the inside edges and the outer edges. But this point still has, yeah. The fuck, one sec. Uh, 4444, 4488. We should be able to get... I still wanna... that's not what I wanna open. I still think we can do... Min tessellation, max tessellation. So with this we get this one. Wonder if we want to do... Output dot test is equal to... One point zero divided by tessellation amount divided by modulus min tessellation factor divided by max tessellation factor. What an annoying problem. I mean, okay. Oh, fuck. If if the distance of the point if the distance if the distance to the edge is smaller than the maximum tessellation amount distance. Ah, fuck. Probably do something with that. Probably gonna have to do something, some special branch case with the edge, but I would like to avoid that. If we take maximum, if we take a maximum tessellation here, so in this case we get 8, or what is it? 1, 2, 3, 4, 5, 6, 7, 8. 1 divided by 8, or is it 0.125? So if the distance to an edge is less than that, but then we're gonna get these as well, and we don't want that. Like, it's like we want to mark this one as a new vertex, but we don't want to mark this one as a new vertex. Probably want to use this together with, I think we're close. I think we want to use this together with the inverse slurp thing we have, where we compare the maximum and minimum tessellations. Tessellation amount for a point. Can we do... So by doing output inverse slurp, min tessellation, max tessellation, And then we just do output.test is equal to output.test bigger than 0.5. Then we get so these points are closer to being one subdivided once more. These ones are closest to being subdivided one less. So pretty much, if we just take this point, for instance, this one is tessellated once more than it actually should. If we could do tessellation based on per point, but then again, so then I wonder if we can do let's do this. If output.test is greater than 0.5, we do this, else we do this. Let's see if we can get it working with the branch, and then we can see if we can clean it up. The compare value 1 divided by max tessellation factor divided by 2. And here we do compare value 1 divided by min tessellation factor divided by 2. Same issue here. This looks pretty good. Why does this one give... This one is... So all of these are black, that's good. Here it seems to work, but here... So if it's black, it's a new vertex, and we can see here, this one new, 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 new. All of these are new, but we still have the same problem with this one. Minimum tessellation factor, this one should be marked. Is it because... Max, min. I have no idea what's going on here though. Look at this. I'm gonna need a new cup of coffee for this. I really want to get to the bottom of this, so I'm just gonna run AFK for a couple of minutes. And hope I have a plan when I get back. So be right back a couple of minutes. Okay, back. Sorry about that. Let's see if we can solve this. Problem that shouldn't really be this difficult. So we have some functionality in place that properly identifies new vertices relative to subdivision amount. So the black vertices we can see here. The only problem with it, let's see here, tessellation. Only problem being edges. So we need to handle I'm talking about this right here. If we just went about this as it is, we're going to get seams at this point, because we can see this quad marks this one as a non-new, or as a new. This quad marks this one as a non-new. We want this quad to mark this one as a new vertex as well, but we also want it to mark this one as an old one. If we calculate tessellation factors per point, we saw that we get like if we mark vertices based on if they are closer to be to the minimum tessellation amount or the maximum tessellation amount, we're always gonna highlight the vertices closest to the camera. That's true. Could we make if we set the vertices okay, so for this one we have a maximum tessellation amount of 8, which means that our smallest step in this one is 0.125. This one is at that step, this one as well. But not this one, but this one is... And it's not enough to binary mark them as new or old. We also want to figure out how new and how old. So in that case, it's very important that when we move on to age as well, we want this one to be represented by the same age for both of the quads. If we take close to it, so we calculate the maximum tessellation amount for the full and the minimum tessellation amount for the full. Then we just need to figure out how close do I care about. Maybe we can make some nice assumptions. I want to do our max, since we take the max subdivision of all edges. So this point and this point, this one gets subdivided. Like that's what bothers me about. I don't want to do this, but I want to do. We do this again. Calculate the tessellation amount for the point in question. Then compare it to min tessellation, max tessellation. 0 if it's min. 1 if it's max. Oh yeah, 1 sec. Yeah, we're pretty much gonna get a binary value from this one. Except for here, when I have more fine grain, that's true. Okay. Can we just make this squared? Or if we make it relative to relation max amount. Ah, fuck, we can probably work with this, honestly. Can we? Why do we still... Oh, yeah. Or what I'm wondering is why we still get pure white here. That's a little bit weird. Or no, it's... Yeah, it is. We don't tessellate this the maximum amount. Calculate tessellation amount, position center VS. Ah. There we go. Okay. Not sure this will help us, however. In this specific task. Actually, let's just copy it. This we need to handle as well. What do we have? I have a tessellation amount of 0 for this one. That's not good. Or 1, actually. 1, yeah. Don't care too much about this right now. Look at this case, for instance. Here we have 3 edges where we want to do... where we want to mark 0.5 as old. And 1 edge where we want to mark 0.5 as new. Actually, I think we're gonna go with one of the ugly solutions. Like if we can find out if we're located on, like, how will that work with age though? I wonder. Because we could basically just, if a point lies on an edge, an outer edge, then we just use that that edge subdivision amount as the relative value, which would fix this. But then when we go with age, probably, maybe we don't care that much. It would be much better to get a, like, real amount relative to least. Which makes me think that I've been going in circles, because I think for the third time yo, what's up, Tar? For the third time, I think we're on to something when we do... Where do we have it? This one. But we do max tessellation factor, min tessellation factor. Gives us a value between 0 and 1. And then we do... Or have you watched Invincible? I don't think I have. Let's output this 1 sec, and I can show you what I mean. We can probably get a good age here, I reckon. Let's see. The problem is... This sucks, yeah. So we would actually... Oh, that makes sense. Yeah, okay, it makes sense. We subdivide one less time here. Tessellation amount, yeah. What I want to do is power of 2 screws us over here, I think. We get more truncated values than we would like. Because for this one, we want a value between, like, the final result we want to be a value between 0 and 1 that gradually interpolates between those two values. Here we get either, most of the time we get 0 or 1. Sometimes we get 0.5. Like, if we just wanted the full terrain to gradually displace as close as the closer we get, it would be way more straightforward, I think. But now we always only want to do it with the new vertices. So as we move closer to a terrain, we pop in new vertices. These will be... Oh, that's true though. Like, we want to pop them in, but we want their position to be interpolated between their neighbors, and then the closer we get, they fall back to their actual value. That unfortunately means and we're gonna have to do some interpolation here as well. Might be a bit more complicated than I initially thought. But like the first problem, can't even get that right, is to just be able to identify the proper vertices. That includes the seam vertices. Oh, can we do... I'm wondering if, let's do this. I just want to see what we get when we do output.test is equal to if we do factors dot edge 0 plus divided by 4 is equal to we get it. There we go. Huh. When it's uniformly subdivided, mark those. Here we have some problem. Can this help us? No, I don't know. Yo, what's up, Robert? Are you making your own LOD implementation? That's basically what we're doing. But not really. It's just for... It's our own LOD implementation for tessellated meshes, I would say. A little bit worried about this one as well. But I guess we get S divided by 0. Doesn't Unity have LOD already? It has. But not for this specific case. Fuck, I hate this. Let's continue with this one and just do, I want to do output test value. And then we do output.test equal to I wonder if we can, okay, so let's, with this one we have the, so just for one quad we have marked the new vertices. I just want to see if we can output the age of them properly as well. And this, so for this new vertex, when we calculate this one, gonna have to go down to this one, this one, this one, and this one. Then interpolate the height. But I think we can manage that. So basically for all the I want to calculate for all the black vertices, I want to calculate how close are they to no longer being the max tessellated factor. To do that, I think we're gonna have to do we want to do this and this. Yeah, I'm thinking that we might want to work with distance here instead. Instead of tessellation. Robert, doesn't OpenGL has its own tessellation mechanism? I don't know about OpenGL, but we're doing HLSL here. And we're using tessellation shaders. Let's see. If we do... Yeah, I want to work with some floats here, so we're gonna do... Calculate distance. So pretty much this, but the other way around. So square root of tessellation amount. We have a round here as well, that's true. I don't care about that one. I think we can do this. Square root tessellation amount, inverse lerp between 0 or actually 1 and tessellation max amount. Let's do inverse lerp 0, 1 here. And then I want to do a return lerp between 0 and tessellation max distance t. That's about it, right? So with the use of this one right now, we can calculate how close something is to being either tessellated one more iteration or tessellated one less iteration, I think. Let's check. Let's try it. So basically what I want to do is I want to take, let's take these two. Position V as center. Calculate distance to camera. And then we do output.test is equal to inverse lerp 0, 1 between calculate distance, min tessellation factor, max tessellation factor, distance. Oh yeah. We want to do it like this. I thought, yeah. Although I am a little bit... Okay, we get grayish here. Should still be seeing more of a gradient here, I reckon, because we have okay. This result doesn't make much sense, does it? Or actually it does. Minimum for this one, and then maximum for these. Ooh, this we might be able to use. Interesting. Although I'm a little bit worried about this gray here. I wonder if we should just get... maybe not. Might be able to use this. Looks very good here. Although... okay, so at this point, we subdivide this one more times than this one and this one, but this one is extremely close to not being subdivided at all. Then we get closer, makes more sense, and when this one turns full black, so then we only have these. Okay. Okay, we might... so this might be our... when it's full black, that's when we displace it to fully represent the height map. And then the whiter it is, currently we might flip it, the less we displace it. This is still... well, still a little bit worried about this one right here. True, we are still gonna have the same problem with this one. So do we have it? Yes, we're still gonna have a problem with this one right here, I think. Hmm. Yeah, it won't help with this. Don't think. Like, we have come way further than with the triangles. So I'm happy about that, but this problem. Zero 0.5. Like, if we take a look at the UVs, this one has 1, 0.5. This one has 0.5, 0.5. And this is an issue we need to solve as well. This one is crazy, this one. Because here we have... This one is subdivided 8 times. And it's neighboring a quad that is only subdivided 4 times. Actually, this one is subdivided 16 times, and this one is only subdivided 4 times. Definitely need to be able to handle that. The information we have is edge subdivision. Okay, let's do some drawings. I'm not getting anywhere here. Just looking at this one. So let's say that we have one quad. We fully subdivide once like this. That's not exactly how it looks either. It's very annoying. Basically, we can do it like this. One, two, okay. Maybe. Let's see here. I'm always falling back to getting the closest edge. But then how would one handle a point that is right in the middle of the 4 edges? Average edge. What the fuck? Let's see here. Let's take up a notepad. If we were to take the UVs of the average, so for this one we would actually get 0.5, 0.5. Actually, let's say that we take the average subdivision amount. So here we have 2, 2, 4, 4. So for this one we would get 2 plus 2 plus 4 plus 4, 12 divided by 4. 3, right? Right, we have min is 2, max is 4. Average for middle point is 3. Average for this one right here, it depends on how we average it, but for this one we could probably go and we multiply it with 2, 4. This one is way closer to 2. So if we calculate the weighted subdivision of a point and then we're gonna try it. Weighted average subdivision amount. That's right. Good question, Harukanan. Kalkylatorn, still notepad. Does this really give us something we can use? Fuck, I'm annoyed by this shit. So in this we would get 2. Now, for this point, we would still be getting actually relative distance to the edge, relative distance to some edge, the closest edge. Maybe. I'm thinking each point, we did something similar. For each point we calculate not this, but we calculate what if we interpolate the subdivision with a point? What does that actually give us that we don't already have? I think we only need to care about don't closest edge. What annoys me with this problem is that we're so damn close. So damn close. I mean, we could do tessellation amount. So max tessellation factor for this quad, min tessellation factor for this quad. Tessellation amount for this vertex based on position center vs. What if, and then if we do this again, but might get 0.5s here. So I wonder if I want to do, but this one is not it's not the proper way to do it. Because if we take a look at it again, we might get is it the proper way to do it? We're gonna get points here, that's true, but this one pretty much returns 1 or 0. Then if we do output.test is equal to, I want to do factors, this one. Min tessellation, max tessellation. Let's do what compare value is equal to tessellation amount. Can we do it like that? Get a sync, we lose these though. We get them back when we get closer. We always get a sync between edges. I wonder. Except for when we have this special case, but we lose some vertices we want right about here. Or actually, do we? White are currently the new vertices. Or no. White is the old vertices. That's one step closer, I think. We always get a sync-ish. Relation amount. Could this be a floating point error? Possibly. Nah. But we want to do if it's not true. And the problem with going with min tessellation factor is fuck, we don't even get a sync. that point. So close, so close. Just this max tessellation factor, we need to switch it. One. It's just about, honestly, when we're closer to the camera, use max tessellation. When we're further away, use min tessellation. But then we also have an issue. It really should be as easy as that. Pretty much like we did here. What do we have? Tessellation amount. We calculate tessellation amount. Inverse lerp, min tessellation, max tessellation. Tessellation amount. Let's just do something ugly like this. Float. Compare tessellation is equal to output dot test. It's bigger than 0.5. Doing some weird stuff now, but then we do compare tessellation here. We lose some new vertices here, or some old vertices here, but that might be okay. But other than that, does it work? Yeah, then we get this problem. Are you serious? Doesn't even work for this one. Yes, it doesn't work here because it's actually close enough to the camera to be... So it would have to be, if it's bigger than 0.99 maybe. Not even that. Kardarv, what's up? What are we working on? We're doing some tessellation here, which eventually is going to be used for snow. And we're trying to solve the issue of popping. So the closer we get to this mesh, the more vertices we use to represent it. So when you get within a threshold, we represent it by double the amount of vertices, and we want to identify which are the new vertices so we can adjust their displacement a bit better. I can probably show you soon or later what we're working on more specifically. I mean, this works. Here we have this issue. What the hell is this issue? Yes, we lose vertices here, so probably bigger than 1. Still doesn't work. So it's pretty much this problem we're trying to solve. So new vertices, so you can see the closer we are, the more vertices we have. New vertices are represented by black and old vertices with white. But then we have this problem. So this patch is not subdivided as much as this one. So we get a little bit of a seam here. Yeah, it's extremely interesting, but also fucking complicated, man. Right, for this, I think the last 2 hours pretty much shows that in this specific case, I have no idea what I'm doing, but it's a learning experience. Okay, we're gonna try and do this. This might be a bit, instead of using tessellation amount from position here, we're gonna use we're gonna do a lerp. We're gonna do tessellation amount interpolate bilinear. Although I wonder, let's put UV here. util math, interpolate by linear. Where do we have it? Interpolate by linear. We do P1, P2 is X. Okay. So if we go by this knowledge, P1, P2, X is in this direction. So we want to use edge 1 and edge 3, right? Zero. I want to try this. So then we have tessellation amount here, and then we do tessellation amount here, compare tessellation here. Do we get... we don't want to use input, we want to use factors. Oh, yeah. These are integers this time around. Part of learning and problem solving, I guess, takes a toll on your mental. This time it does. Yeah, it's a annoying problem because we're extremely close to solving it. Or that, at least that's what I'm telling myself. But we can't quite just reach it. Okay, I don't want to implement this one with something else, so we're gonna do I think we're just gonna do float tessellation amount is equal to lerp between these two, x. How would this work? We want to lerp between this one and this one for x, and we want to lerp between this one and this one for y. And then we take here, we have a point. I want to do like weighted subdivision. So but can we just do we pick the closest of these two, closest of these two. if we just take the closest edge, that should tell us. But then again, we have the inner edges to care about as well. Do we really? I don't think so. If we do, we want to calculate tessellation amount. As the tessellation amount of the edge we're closest to. So I just care about outer edges. So it's U and V we're gonna go for. But then remember, we have an edge at U equals to 0 or 1 and V equals to 0 and 1. So I reckon we could do let's do float 2 UV transformed equal to UV is it minus 0.5. Zero becomes 0.5, minus 0.5, 1 becomes 0.5. 0.5 minus this. Abs. If it's 1, 0. If it's 0, 0. 0.5 becomes 0, 0. And then we want to do we get which one is closest. We don't get the closest. You can probably do it. Let's do it the ugly way. If let's do tessellation amount 0, and then we do if x uv transform dot x is less than uv transform dot y, do this else. And then we do flow out tessellation amount. We already have it. So tessellation amount is equal to, so in this case x is the smallest in uv transformed x. So then we do uv.x is bigger than 0.5, then we return and that means that we're here, so we want to return E3, right? So input, no, what's it called? Factors, edge 3, otherwise factors.edge 1, if I remember correctly. And here we do y 2 and 0. Is this the correct way? We transform (0.1), for instance, minus 0.4, 0.1, 0.9, 0.4, 0.1 is the smallest one we care about. Okay, something like this, and then we do tessellation amount here. If else, what am I missing? This one is closest to it's closest to this one. We don't subdivide this one as much. Jesus. Still not correct. honestly, let's take a look at this. I think we could do... Okay, if we do this in the worst way possible, the implementation, now I'm at the stage where I just want to make this work, no matter how it looks. Then I think we could do... let's see here. Tessellation amount. Then I think we could do this. If uv.x we could probably do this. So we do it like this. Compare value is equal to 1 divided by max tessellation factor. We do it like this. Float tessellation factor is equal to max tessellation factor. And then we set this one here. And then we're going to take care of the edge cases. So then we do if uv.x is equal to 0.0, one edge case. If uv.y is equal to 0.0, another one. If uv.x is equal to 1.0, and then if uv.y is equal to 1.0. The 4 edge cases we have. And then we just do tessellation factor is equal to minimum tessellation factor, and so for x equal to 0, we care about 1. If y is equal to 0, we do 0. If x is equal to 1, we do 3. And then I guess we do 2 here. If none of these are true, we do max tessellation factor. Otherwise, we do this. So handle each edge case like this. Yeah, let's see if this works. So black vertices are new vertices. White. Is this really true? White, 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 white. Hmm. What edge case did we miss here? up, Harshitson? Don't know if I'm the correct person. Maybe someone else in chat. This is insane. Why do we get this result here? What edge case are we missing here? Here as well. Okay. Am I doing something wrong? Hmm. 0, 1, 2. Fuck. 0, 1, 2, 3, 0, 0, 1, 2, 3. I've been working with the wrong. So if we look at this one, for instance, this one is on UV is equal to 1, which means that we should go 1 lower. So this one should be black. If we bring back this one. Okay, that works here. But here it breaks. Why? This is beautiful, I think. 1 black, 1 black, 1 black, black, black for all of these. Then we have 1. So here it works. And what do we have? Let's go down a bit. This is exactly what we want. Every other black and white on the seams as well. But if we turn to around here, it starts to break. This one, correct, this one not. Here we show 1 less, here we show 1 more. Min, 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 min. Do we want to handle this? Yes, it breaks because we have Okay, we're gonna try one more thing. It's here. 1 and 3 are X. 2 and 0 are Y. So let's do it as float. Y max tessellation factor. Y was E2 and E0. So 1 and 3. And then let's do X tessellation factor. Y tessellation factor. And if so, we can probably do it 3. Something like that. Y 0 2, right? Yeah. I wonder if we just want to keep it simple. X compare value. Y compare value. And then something like that. Sing this time around. And this sucks, but this might just be one. So we have a problem when we are at the lowest possible lowest possible tessellation, we get an error otherwise. Am I missing something? One. Yeah, we want this one to be do we? Two. Let's go with 3. So if we subdivide this once more, we get this, this. But these are actually new as well. Yeah, we don't get all the new ones. That's why we need to have this one. So let's see here. 1 are old ones. Old. This is the pattern we want, but this one is wrong. To have, so here is y equals to 1. This one should be true. By tessellation factor. Tessellation factor for this one right here is 4 undivided by This one being white in this case. What am I missing? Hmm. Hmm. Should be no difference. This we don't even need to calculate. It's almost like we don't take this one into account at all. But do we have the same? We have the same problem here actually. At x1 and x0. Which makes me want to test. Really? Let's double check this one first of all. UV center X. That's better. Y. Oh yeah, of course. Okay, this is interesting. Ooh. So we want to do UVXY here, but let's see. UVX does not correspond to what I think it corresponds to. UVX don't think it should have screwed with anything we have done so far, but for all the things we've tested so far. But it's this one we want to use. And so then is it UV X? How do I want to change this? So X is 0 and 2. Y is 1 and X. 0, 2, 1 and 3. And then we remove this one. If X is 0, we get edge 0. If X is 1, we get X2. I want to 0, 2. If X is 0, we do the 0. If it's 1, we take 2. And then we do the same for Y. If it's 0, take this edge. If it's 1, we take this edge. So what the fuck? Mm-hmm. Now I have no idea what's going on. This should We don't care about those. X max tessellation factor between edge 0 and 2. We set this one to be equal to this one, and then we do bottom one, X compare value. I just want to see what happens if we do change, really? There we go. Then again, UVX is, let's change this one to less than 0.01. And greater than 0.99. Ah. We don't really see any difference with or without this one, right? Don't. It's probably, let's see here. We only want to mark it as white if both of these are true. The and here is correct. Look at this. Beautiful. not so beautiful. This means that for this point here, we get the y should take care of this one, because y is equal to 1. Oh, I might. Is that because... Oh, I wonder. This is weird. Why doesn't this check work? Else if what if we do okay, I just want to do let's try something weird here. Let's do thousand divided by 2. Yeah, we should go get all black here, I reckon. Hmm. Okay, let's do back with this one. And we do this. And we put 1,000 here. Okay. So the check works. Factors edge 2. By doing this, we should be getting one factor less than max. Although that's not the case. Oh. This one might screw us up a bit. Or no. If we do the division here, it might. This is all very weird to me, but I'm also extremely tired now. This problem is one hell of a problem. But I gotta run now. If you want to see me bang my head against this one tomorrow as well, feel free to join. Once again, we're extremely close. Just have to get these special cases in order. I have no idea what this branching doesn't work. But yeah, let's try it again tomorrow when I'm fresh. Thank you so much for sticking with me. I appreciate it. And have a great rest of the day. Peace.